right, thank you. It is great to be back at NACIS. I have to admit, regrettably, that I haven't been here since it was last in Minneapolis, but I have enjoyed it in the past, and I hope to, after seeing all these great presentations, visit a little more frequently. I'm really glad, though, it was great timing that you had it again in my town this year, because although I am only an occasional cartographer these days, just this year, I had the opportunity to post this new blog post from February, not so new, I guess, that is really well suited to PCD. And as soon as I heard that this was going to be here in Minneapolis, I just got to come up and do this PCD thing. I didn't realize how much competition there was for amazing PCD talks today. So I hope I fit in. The subject of this talk is census centers of population. So what I do in my day job is prepare data products for our website, IPUMS, and specifically for the NHGIS. And one of the products that we have added to our website is census centers of population. You can use census centers of population in all kinds of population mapping in the US in really interesting ways that I think I'd like a lot more people to learn about. The way that you've probably seen these things, if you've seen them, is this map. It's been around for a really long time because the census has been computing centers of population for the US for a very long time. And after each census, they update this map with a new point. And what they've computed is approximately the mean coordinates, latitude and longitude, adjusted for this, the sphere of the Earth, for each census across time, for the entire US population. And you can see how it's traveled steadily west and somewhat southward over time. And, well, that's interesting, but that's one map. Okay, so how can I use census of centered populations for anything else? Well, you can, because since 2000, the census has also published them for states, counties, census tracts, and block groups. And this is where things get interesting. If you want to get them from the census, you can only get a CSV file with a Latin long. To save you a little trouble, on NHGIS, you can get shapefiles. So go to Get Data, choose any of those levels or any of those years as your data filters in our data finder. Choose the GIS Files tab, and you will see, in this case, 4 2020 shapefiles available. We also have the 2010 and 2000 shapefiles. I was just thinking, we need to start making new ones. We could easily extend this to CBSAs and some other things. Someday. We have such a long list of things we want to produce for you guys. But right now, you can get these. And what do you do with them? Well, you might make a proportional symbol map. These are not centers of population. These are the default placement in ArcGIS Pro. For the most part, I think they're centroids, but you'll notice Fresno, right around here, is off on the side of the county. I think there's an algorithm behind this that says, the middle of Fresno County is too close to a boundary, so I'm moving this over to a larger section. So things get pushed around a little bit with the default placement. An interesting question, though, is where should the circles be? I perused a few cartography textbooks. I didn't really see anything about placing proportional symbols in areas. So I think the general, cartographic philosophy has been in the middle someplace. And that makes sense. If that's all the information you have is the area, you put it in the middle of the polygon, and that's reasonable. But I'm mapping populations. And populations are often not in the middle of counties, especially not in Nevada and California. So you have to ask yourself, am I trying to map where counties are or where people are? And with a population map, I would generally prefer the latter. And that's what centers of population allow you to do. Starting with the population of Reno, which is gladly making a return from its visit to Burning Man, and all over northern Nevada, and down here in Nye County, you've got people moving closer to Las Vegas. Throughout the desert regions, you see some more moves over in Arizona as well. All around Los Angeles, the people are part of this big conurbation, and you see that in these proportional symbols. Along the coast, people live on the coast. In the Central Valley, people live along the Highway 99 corridor. And you see that really clearly in these centers of population. This is all county data, okay? So we've been taught, like, well, if you're dealing with large areas, you just can't get that precision of placement that you would with smaller fine-grained data. Well, you can if you use a properly placed symbol. So this is a pretty good representation of the population distribution, despite the fact that I'm using really big counties to map that. And it's true elsewhere throughout the West. You can see on the left how those circles are up in the mountains along the coast, not actually along the I-5 corridor, or on the coast, or along the Columbia River Valley. And down here in the empty quarter of southeast Oregon, there's a couple of counties where almost all the population is close into Boise. You can see that pretty clearly on the centers of population map. Farther east along the Snake River, there's a very clear pattern in the centers of population. There's a clear pattern down the I-15 corridor in Utah, and you clear out some of those empty quarters there as well. Along the Front Range in Colorado, and even on the north edge of the Black Hills in South Dakota. Once you move further east in the country, these things aren't as dramatic because the counties are smaller, populations are, agricultural populations especially, they're pretty well spread out within counties. So the centers of population tend to be in the center of the county. But even in some areas, there's larger counties. You can see around Duluth, there's some concentration of population and population along the shoreline. And Minnesota also has an empty quarter up in the peatlands way up north. Similarly, northern Maine has an empty quarter. And then we also have the old Erie Canal corridor. In Florida, everybody lives on the coasts, right? So you can see that pretty clearly with the centers of population. We also have an empty quarter in the Everglades that gets cleared out. Lastly, Alaska also has a coastal population up in its northern far reaches. That's just counties. The fun part, the really fun part gets to be when we're looking at these really small areas, because you've probably wanted to try to make a dot map sometime. You learn very quickly that dot maps are spread around randomly unless you do a lot of work to put them in a useful place. Use these centers and they're already in a useful place. These look an awful lot like dots because tracts and block groups have similar population sizes. So just like on a dot map, most of your circles are about the same size. And these are optimally placed. They're optimally placed such that throughout the hills around San Francisco Bay, you would ordinarily see lots of dots up in the hills with a normal default placement. But with the centers of population, you can see that the population really is clustered in the valleys. And you can go even finer grained with block groups. It looks like a dot map. But I didn't have to worry about placing any of these dots. They're optimally placed. Okay, so that's great for population distributions. Okay, so, proportional circles are great for measuring, mapping size. Well, for the second part of my talk here, I want to make a big spiel for bivariate proportional symbol maps, because they are kind of like centers of population, an underutilized resource, although we've heard of them before. You can map population characteristics with proportional symbols if you vary the colors of those symbols. This map is showing the percent of population that's under 18. And because the circles are sized according to population, it's a lot like a cartogram, except easier to read, easier to recognize the locations. And you're really looking at the distribution throughout the US population here because you're not emphasizing all those empty quarters that ordinarily get a lot of space on a choropleth map. Out here in the salt flats, I don't think there's many children at all, but that bright orange is really taking up a lot of your attention. Similarly, there's about 15,000 people in these two counties in New Mexico, but that contrast around those dark blues draws attention. We know about a lot of these problems with choropleths, but it's still the easiest thing to do. People recognize it. I don't find proportional symbol maps that much harder to read, and they answer some key questions that you can't do on here. Which major cities have the lowest shares of children? Well, we have several major cities that are in the smallest counties in the country. It is really hard to see those on this map. Here, it is easy to see that San Francisco, New York, and Boston all have very low rates of children. I couldn't tell you that at all from the choropleth map. So I'm already sort of past promoting centers of population here. Most of the advantages of this map are in just making a bivariate proportional symbol map. But as I said, because I'm using centers of population, I've cleared out those empty quarters as well, and I'm putting the people where they are. And here you can see those two counties in New Mexico. They've become much less emphasized in this version. And you can do this with the smaller areas as well. Here's the San Francisco Bay Area. I'm seeing really interesting things here about different parts of the city have very different age compositions. There's places where children live, and there's places where children generally don't live. And you can see it down at the block group level as well. And compare this for a moment to how messy this choropleth map is, how many boundaries and edges pop out at you that have no relevance to what you're interested in at all. Particularly, like a big tract up here that has just a small population and is dominating what you're seeing up in that area. You can do this at a smaller scale. Even with tract data, this is still quite legible. I don't know how it reads in the back of the room. You can do it all across the eastern seaboard. And lastly, you can do it with all kinds of characteristics. One more plug for NHGIS here. There's a couple other tabs here. We've got all kinds of ACS and census summary tables. We've got time series tables that have standardized 1990 through 2020 census data for 2010 census areas. So using 2010 block group centroids, I can map change from 1990 to 2020 here in the Twin Cities. I can do it for each decade in turn. There's some really interesting things I'd like to talk more about there, but I'm running out of time. So I'm just going to end with some technical tips about how I did this. I did this all in ArcGIS Pro. The first option I considered was, okay, start with the proportional symbols and then vary their colors by attribute. The problem with that is it's a continuous color scheme only. I'd like to use classed colors in my examples, and that was really hard to do. And if I want to copy a layer from one data set to another, this size scaling is always based on the smallest value in your data. So when you copy that layer to another, it rescales everything. That is really inconvenient. I have to do some math that I don't want to do. So instead, I started with graduated colors, which is something you can do with point symbols, but not with area symbols. So just know that you need to start with the centers of population or some other points in order to use this. And then you can vary the size by attribute. You type in an equation, make sure you use a square root because we want areas to be proportional to population, not diameters. And then finally, some design tips. Use transparency and vary the color of both the fill and outlines. If you don't do that, you get what the default gives you, which is an illegible map. The other thing is change it to uniform outline widths so that even the very small centers can be visible. Because if you don't do that, it's pretty hard to see those really small circles. And you can do that with this little option that I had to bang my head for a little while to realize actually exists. But I did find it. Okay, that's it. I just want to acknowledge our funders and thank you all for watching.